Welcome everyone. In this video lecture, we will solve a problem based on the diode, and it is from the Microelectronics circuit book. So the question is for the logic gate shown below. So there is some logic gate. So we have to identify which kind of logic gate is there. Okay. So for the logic gate shown below, assume ideal diodes and input voltage level of 0 volt. So means low level voltage is 0 volt and the high level voltage is plus 5 volt. Find the suitable value of resistance R so that the current required from each of the input signal sources cannot exceed or does not exceed 0.5 zero point 0.1 milliampere. So first we have to identify which logic gate it is. Okay, so we can easily identify. Suppose for a high level signal, I am writing for a high level signal around say plus 5 volt. Okay, or we can say the logic 1. Okay, it can be logic 1 or logic high. Okay, or we can say this one is a high signal. Okay, so if anyone is high, okay, diode will be say this one is say diode D1, D2, D3. For example, very simplest example, I am just saying if VA is high. Okay, high. Okay, or logic high plus 5 volt. Okay, and VB or VC is low, means 0 volt. Okay, so VA is high, so we can say the diode will be on. Okay, D1, but the other one will be off, and there will be like this. The circuit will be R, VY, and I am saying this should be 5 volt, and one can also say means D1 is on, and remaining two D2 and D3 will be in the off state. Okay, so these two will be the off state, so D1. Okay, so this one, so if any one of the input is high, means if VB is high, I am writing high, VA, VC 0. Okay, or low, again this will give the high value of voltage. Okay, so basically this one is a, it concluded this one is a OR gate. Okay, means once again I am doing by using simple. Suppose instead of three inputs here, you can consider two inputs, say A and B, and say Y. Okay, so I am just writing A B Y. Okay, so now what we can say, if both will be zero, if we are just forgetting this part. Okay, if both are zero, the diode will be in reverse bias. It is open circuited, so output will be almost zero. If anyone is high, for example, anyone is high, like P is high. Okay, so if anyone is high, this one will be on and this will be off. Okay, so but this one will be off and this one will be on, so it will be sorted. Okay, so it will be high. If this one is high, A is high, means high value plus 5 volt, so it is on. B is off when 0, but it will remain 1. The same input voltage will come here. Okay, when both are 1, so simply 1. So this is nothing but simply our what, OR gate function. So this is represents a OR gate. Okay, OR gate. So this one is a OR gate. Okay, so now see in OR gate, any one of the input is high. If any one of the input is high, output is high, and both are, when both the input are 0, it should be 0. So this one is a OR gate. So in general, we can say the circuit, and here we have to find the value of R. Okay, we have to find the value of R. Okay, in such a way that the current required from each of the input signal source does not exceed 0.1 milliampere. So the I value does not exceed, means this ampere, 0.1 milliampere current. Okay, so for what condition it is feasible? So what we can say, for any one input is high, says VA is high. Okay, I am just considering this case, VA is high. So okay, it is sorted. Diode is on. Okay, this one is R. So this will be our 5 volt. Okay, D1 on. Okay, D2 off. So no need to mention. Okay, when 0 volt. Okay, when it is 0 volt, I'm just making it 0 volt. Okay, so no need to D2 of D1 off. So 5 volt will be there. R is there, and we have to find this current, say I. Okay, so in general, or we can very simply we can make this circuit very simple like this. This one is 5 volt and this one is R, and some current is flowing, say I. So this I can be written as 5 minus 0 by R. Higher potential minus lower potential by R. So this I value will be this. So now I value should be less than equals to 0.1 milliampere from this dynamic shift. So I value can be written as 5 by R value should be less than equals to 0.1 milliampere. Okay, or 0.1 m. Okay, so now R should be a positive quantity. Resistance will be a positive here. Resistance is positive quantity. Okay, greater than 0. R will be a positive quantity. So what we can do here, we can write 5. This R we can put here 0.1 milli. Okay, so 10 to power minus 3 R. Okay, or simply R can be written as R greater than equals to 5 by 0.1 into 10 to power 3. Or if we put this, if we remove this decimal, we have to again multiply with 10. So simply we can say the R value should be greater than equals to 50. Okay, and this is correspond to 10 power 3 kilo. So R value will be greater than equals to 50 kilo ohm. Okay, so first we have identified this one is which gate, or gate. Okay, because any one of the input is high, the output is high, and both are inputs are 0. In the same case we have 3 inputs, so no need to worry. Okay, using 2 input also we can, or any one of the input is high. Okay, so the 5 volt will be come here, 5 volt. Okay, so that's why this range is 5. So here I am just simplified this one 5 volt, this one grounded. So I current will be higher potential and lower potential by R. So this one is the expression, and here it is already mentioned the current value from any of the sources, input signal sources, does not exceed 0.1. So I value should be less than equals to 0.1 milliampere. So I is 5 by R, so 5 by R. So then if you solve, so R value will be greater than equals to 50 kilo ohm. So for this question, the R value, the R value will be always greater than equals to 50 kilo ohm. Okay, so this can be easily identified by this secretary. Okay, and this one is a OR gate, and this is from the microelectronics circuit book. So the answer is, for the R value, this R value will be greater than 50 kilo ohm. This is all about this simple question. So thank you for watching this video.